Dear student, I am Manohar Patil. From the today, we have to start a MHT CET 2024 lecture series. Now this is the lecture number first. In this lecture, we have to study about the unit and dimensions. In that chapter, we have to study how to calculate the dimensional formula for the physical quantity in every in every examination, that is the NEET examination, JEE examination and CET examination. They always ask the questions on this topic, so topic is very important. And from today I know that your state board examinations are finished, so therefore this time is very precious for the study of CET examination. So for that we started the first chapter, so that is unit and dimensions. So let's we start. We have to solve the dimensional formula for physical quantities. Take the first example, that is force. So very important physical quantity. What is the formula of force? As we know that force equal to mass into acceleration. What is the SI unit? So SI unit for force is, that is kg. Acceleration measured in meter per second square. So according to that we can calculate the dimensions. So dimension is for kg, that is m raised to 1, then for meter that is L1, and for second that is t raised to minus 2. As we know that the force and the thrust both having the same physical quantity. Next physical quantity, that is work done. What is the formula of work? Force into displacement. What is the SI unit? That is Newton meter. And as we know that, you have to remember the dimensional formula for the force. So therefore we can calculate the dimensional formula for work done, that is m1 L1 t minus 2. This is the dimensional formula for the force. And what is the dimensional formula for meter? Distance means, that is L1. So we get that is m1 L2 t minus 2. So you have to at least remember the dimensional formula for two physical quantity. One is the force and second one is the work done. So very easy to remember, that is 1 1 minus 2 for the force, and then 1 2 minus 2 for the work done. And we know that torque. What is the formula of torque? Very easy quantity. So torque equal to force into perpendicular distance. So that is having the same SI unit, Newton meter, or we can say that joule. So therefore the work done, torque, potential energy, kinetic energy, that's mean all kind of energies having the SI unit is 1 2 minus 2. Remember the formula. Now we go for the next physical quantity is, so very simple, that is pressure. As we know that pressure means force divided by area. So what is the SI unit? Newton per meter square. According to that, what is the formula of Newton? Dimensional formula. The dimensional formula is m1 L1 t minus 2. Then dimensional formula for meter square means area meter square, that is L2. So 1 L get cancelled. So we get that is m1 L minus 1 t minus 2. Remember, this is the dimensional formula for pressure. Also stress. Stress means normal pressure divided by area. So same dimensional formula. Also modulus of elasticities, bulk modulus. Modulus of elasticity, bulk modulus, all four physical quantities having the same SI unit. So remember which of the quantities having the same SI unit. You have to remember this also. Next, linear momentum. Remember, many times they ask the linear momentum having same dimensional formula is which quantity having the same dimension as the linear momentum, that is impulse. So what is the formula for linear momentum? It is denoted by letter P, mass into velocity. And then formula for impulse, it is denoted by letter J, equal to force into time. So what is the SI unit for momentum? That is mass measured in kg and velocity is meter per second. So according to that we can solve the dimension. So that is kg measured in mass, that is m1, meter, that is L1, and second t minus 1. So remember m1 L1 t minus 1, and then Newton second is the SI unit for impulse. So we can calculate the dimension of Newtons, as we know that m1 L1 t minus 2, and second dimension that is t1. So minus 2 minus 1, 1 get cancelled, so we get m1 L1 t minus 1. So remember linear momentum or impulse both having the same dimensions formula. We go for the next. That is the most important. Many times they ask into the NEET examination, CET examination, that is the Planck constant. Planck constant, as we know that what is the value of Planck constant? 6.63 into 10 raised to minus 34 joule second. Remember this unit, joule second, and as we know that joule having the dimension formula m1 L2 t minus 2, and then second that is t raised to 1. So it becomes 1 get cancelled, so we get that is m1 L2 t minus 1. So which physical quantity having the same dimensional formula as the Planck constant, now it is asked into the CET examination, that is the angular momentum. So angular momentum is, that is L equal to I omega. I means moment of inertia, omega means angular velocity. Angular velocity, what is the unit of angular velocity? That is radian per second, and top moment of inertia, that is kg meter square. Remember the formula of moment of inertia, very easy to remember, that is mass into radius of gyration, that is mk square. So whenever we solve the dimensional formula for angular momentum, it is same as the dimensional formula for Planck constant. These are the both physical quantities having the same dimensional formula. In Karnataka CET, they ask the one question. The question is, what is the ratio? Remember, what is the ratio of Planck constant divided by moment of inertia? We already calculate the dimensional formula for Planck constant m1 L2 t minus 1. So we use m1 L2 t minus 1, and then what is the dimensional formula for moment of inertia? That is mk square, mass into radius of gyration. So mass means m1, radius of gyration means it is the distance, so it is measured in meter, and now here square means meter square, so here L2 T0. So from here m1 L2 get cancelled, so what is remaining? Only t raised to minus 1. So we can write that is 1 upon t. So 1 upon t, it is the dimension formula for per second, and per second it is the unit of frequency. What is meant by frequency? Frequency very easy, denoted by letter F, that is 1 upon t. T means time. So this question asked into the Karnataka CET 2015. So very simple question, we already completed. What is the ratio of Planck constant divided by moment of inertia? Next example. Next physical quantity is surface tension. Very simple to remember, that is force per unit length. As we know that dimension for force m1 L1 t minus 2, and then dimension for length, that is L1, so get cancelled, so we get that is m1 L0 t minus 2. Remember the all physical quantities, these are required for solving the MCQ on the basis of dimensions. Next, most important, that is magnetic field. Next we have to calculate the dimension formula for magnetic flux, and then we calculate the dimension formula for permeability of free space. So what is the magnetic field? Very simple, you can remember the two formulas, that is force equal to I B L sine theta, or one more formula you can remember, force equal to Q V B sine of theta. So out of both you can remember any one formula. So we solve the dimensional formula for magnetic field by using the formula number first. Remember the SI unit of magnetic field, now it is measured in Tesla. So that is we denote capital T later. So from this formula, what is the formula of B? So B equal to force divided by current into length sine of theta. What is the SI unit? That is Newton divided by current measure in ampere, and what is the L? That is meter. And as we know that the dimensional formula for force, so what is the dimensional formula for force? M1 L1 T minus 2. Then dimensional formula for the current, that is A1, and dimensional formula for meter, that is L1. So L1 get cancelled, so we get that is M1 L0 T minus 2 and A minus 1. Remember, this is the dimensional formula for magnetic field, that is having the SI unit is Tesla. Next, physical quantity. Many examination they ask what is the dimensional formula for magnetic flux. So remember the formula, magnetic field is equal to magnetic flux divided by area. So therefore what is the formula for magnetic flux? That is phi B equal to B into A. So the product of the magnetic field and that area, through that area how many number of magnetic line of forces passing through that given area, that's area. So and we know that the SI unit for magnetic flux is, that is Weber WP. So what is the dimensional formula? We already calculate the dimensional formula for magnetic field. So write down here M1 L0 T minus 2 and then A minus 1. And what is the dimensional formula for area? That is L2. So the final answer M1 it becomes L2, then T minus 2 and A minus 1. This is the dimensional formula for magnetic flux. Both are the most important physical quantity in many examination. That is, if you go previous questions, if you solve the previous questions on NEET, J and CET, you observe that in many examples on the basis of dimensions, they ask the magnetic field is required to calculate the dimensions, or they directly ask what is the dimensional formula for magnetic field. Next, magnetic flux. What is the dimensional formula for magnetic flux? Next, we calculate permeability of free space. Very simple. For that, either you will have to remember the SI unit for permeability, or remember the formula. According to that, we can calculate its SI unit. So, for permeability of free space, in 12th we study the Biot-Savart law, that is dV equal to mu naught upon 4 pi I dl sine theta upon r square. So if we calculate this formula, according to that formula we calculate the SI unit for mu naught is, remember the SI unit, that is, so what is the SI unit of B? That is Tesla. SI unit of current, that is ampere. dl means length element having measure in meter, and this is the distance, that is measure in meter square. So 1 meter get cancel and this meter goes to multiplication. So that is Tesla meter and ampere goes to divide. So it becomes, remember, Tesla meter divided by ampere. And in the previous we already calculate what is the SI unit for magnetic field. So we just take the SI unit from this M1 L0 T minus 2 A minus 1, M1 L0 T minus 2 A minus 1. This is the dimensional formula for magnetic field. Then what is the meter? Meter, that is L1, and then ampere, so that is A1. So from this if we calculate, so what we get, that is M1, it becomes L1, then T minus 2, and A1 goes to numerator, it becomes minus 1 and that minus 1 becomes minus 2. So this is the dimensional formula for permeability of free space. And many times I told the student, for the permeability you can remember L1 minus double 2. L1 minus double 2. What is the meaning of that? L1 minus double 2 means this is the L1 and this is the minus double 2, means minus 2 remember. In such way that you also remember that dimensions. So we go for the next dimension. Permittivity of free space. Permittivity of free space. Remember, important है. It is denoted by letter epsilon naught. So हमने already 11th में Coulomb's law study किया है. So according to the Coulomb's law, we can calculate the SI unit or dimensional formula for permittivity. So what is the Coulomb's law? Remember, if you can remember, it's very easy. Between the two charges, we can calculate the electrostatic force of attraction or repulsion. So whenever the two charges, the nature of two charges are plus and minus, there is attraction. Whenever the nature of both charges plus plus or minus minus, there is a repulsion. So the statement started from the force of attraction or repulsion between the two charges is directly proportional to the product of their charges, that is magnitude of charges, and inversely proportional to the square of distance between them. The constant of proportionality now we use here, that is 1 upon 4 pi epsilon naught, and we have to calculate SI unit and dimensional formula for epsilon naught. We call permittivity of free space. So how to calculate? Very easy. So that is the epsilon naught equal to 1 upon 4 pi q1 q2 upon force into r square. So from here we can calculate the SI unit. So what is the SI unit? It becomes coulombs measuring, that is charges measuring coulombs, and there are two charges. So therefore coulomb square, force measuring Newton, and distance measuring meter, that is meter square. So this is the SI unit you have to remember for the permittivity of free space, and from here we can calculate what is the dimensional formula. So let's we calculate. So first of all, remember what is meant by current. Current means the rate of flow of charge. So what is meant by charge? That is product of current and time. So dimensional formula for the coulombs, that is AT, A for current and T for time. So now here that is AT, square it. So we take the square, and then Newton dimension, remember M1 L1 T minus 2, and meter dimension, that is L2. So what is the dimensional formula? Final answer is M goes to numerator, minus 1, 1 and 2, L1 and L2, it becomes L3 and goes to numerator, that is it becomes minus 3. Minus 2 here, it goes to numerator, plus 2 and this plus 2, that is T raised to 4, and A, that is A2. So this is the dimensional formula for permittivity of free space. Next physical quantity is important, that is electric field. It is denoted by the letter E and is equal to, that is force per unit charge. So you can easily calculate the SI unit, Newton per coulombs, and according to that SI unit you can calculate what is by dimensions. So हमें already पता है dimension of force, that is M1 L1 T minus 2, and dimension of coulombs, that is charge IT. IT means we can write that is 80. So it becomes M1 L1 T minus 3. So minus 1 goes to numerator, minus 1 and minus 2 becomes minus 3, and a raised to minus 1. Next physical quantity, most important, that is electric flux. Many times they ask into the CET examination, they ask what is the SI unit and dimension for electric flux. It is denoted by letter phi suffix E. So similar to the magnetic flux, if we compare with magnetic flux, that is magnetic field equal to magnetic flux divided by area. So similarly, we can write down the formula for electric flux, that is E equal to electric flux divided by area. Very simple. So electric flux is the nothing but the product of electric field multiplied by area, or most importantly, you can remember Gauss law also. So SI unit of electric flux is, that is Weber, that is WB, or according to this, that is Newton per Coulomb, and for area, that is meter square, means Newton meter square divided by coulombs. Most interesting quantity, many times they ask SI unit differently, so we can write Newton, meter, and then meter. We split meter square as meter and meter, and coulombs, that is IT. I for current or T for time, that is IT, means IT. So we know that Newton meter we can write joule, and joule per second, that is we can write watts meter divided by current. So remember, this is also one more SI unit for magnetic flux. You have to one more SI unit for electric flux. Very simple. Now we have to calculate the dimension formula. So how to calculate dimension formula? Very easy. So as we know that the dimensional formula for E already calculated, so write down from there, that is M1 L1 T minus 3 A minus 1. So M1 L1 T minus 3 A minus 1, and then dimensional formula for area, that is L2. So it becomes M1 L1 and L2, it becomes L3 T minus 3 A minus 1. So this is the dimensional formula for electric flux. You have to remember, very easy to remember, both are most important. We go for the next, universal gravitational constant. Gravitational constant. So we know that the universal law of gravitation, very easy. The force of attraction between the two objects having masses, that is product of their masses, and inversely and inversely proportional to the square of distance between them. So that is considered, this is the particle, second particle having mass m1, mass m2. So they are center joint their distance, that is r is the distance between both. So the F equal to capital G, capital M1 M2 upon r square. So from here we can calculate the formula for G. So that is universal gravitational constant, capital G equal to F into r square divided by M1 into M2. And as we know that what is the SI unit of force? Force SI unit is Newton meter square, r square means meter square, and divided by mass kg, that is kg square. So according to that we can solve the dimensional formula for the Newton m1 L1 T minus 2, for meter, that is L2, then kg square means m2. So 1 m get cancelled, denominator goes to numerator, so it becomes m raised to minus 1, then L1 and L2 it becomes L3 and T minus 2. So this is the dimensional formula for gravitational constant. In so many exams they ask what is the dimensional formula for gravitational constant, or what is the SI unit also. Remember the SI unit for gravitational constant. Next, in CET examination they ask what is the SI unit of under root of L into C, where L is the C is the capacitance and L is the inductance. So remember the formula of resonant frequency. Resonant frequency, it is denoted by letter F equal to 1 upon 2 pi under root of LC. So tell me, what is the SI unit for frequency? That is per second. So if we compare with, and 2 pi is the constant having no SI unit, only remaining term is under root of L into C. So what is the SI unit of root LC? That is second. So this is the option of given example, means that is the answer of given example, means the SI unit of under root LC is second. That is having the same, that is time. Simple. Next, energy density. So very simple formula of energy density, that is half epsilon naught E square. So energy density means energy divided by volume, and energy means joule and volume measure in meter cube. So from here we can calculate. So यहाँ से तो हम calculate कर सकते हैं SI unit. What is the dimensional formula for joule? M1 L2 T minus 2. Then dimensional formula for meter cube, that is L3. So from here 2 to get cancel. So remaining answer is M1 L minus 1 T minus 2. Next, that is speed of light. Many times they ask what is the dimensional formula for mu naught epsilon naught raised to minus 1 half. So many times they ask the physical quantity and what is the dimensional formula. So you have to remember speed of light denoted by letter C and how it is calculated. So according to the Maxwell, we already in 12th we have to already study light consists of both particles, that is electric as well as magnetic. So electric as well as magnetic, that is, this is the constant of proportionality of magnetic field, mu naught, permeability of free space, and epsilon naught, that is permittivity of free space. It is the constant of proportionality of electric field. So remember the formula 1 upon under root of mu naught epsilon naught, and what is the SI unit? That is meter per second. So this physical quantity we can write 1 upon mu naught epsilon naught minus 1 by 2 becomes plus 1 by 2, and we can write that is mu naught epsilon naught into square root. So what is the SI unit? Meter per second. This is the SI unit, and what is the dimension? That is m1 m0 L1 and T minus 1. So this is the dimensional formula for speed of light. So I hope all of you understood the physical quantities and their dimensions, how to calculate their dimensions, and these are the physical quantities in many examination they ask. So अगर आप इसको writing practice करोगे अच्छे से and you can remember the formulas, so definitely जो final exam रहेगा आपका CET, उसमें आप definitely you will catch that question, you will get out of marks. So I hope if you like the videos, so please like करना है, कमेंट कीजिए, शेयर कीजिए एंड सब्सक्राइब कीजिए. थैंक यू.